morning to all of you. Today we are starting with your remote sensing, that is RSA and GIS, unit number 2. Talking about this particular unit, if you see, this is the basic outline of it, in which we will be going through the various types and characteristics of the remote sensing. Secondly, there will be different types of sensors. We'll talk about the different types of sensors, and we have this orbital and sensor characteristics of major Earth resource satellites. Later on, we will have some Indian remote satellite programs, and accordingly, we will have their open source satellite data portals. And as we have this Indian satellite program, similar way we'll see the global satellite programs also. Then we'll see the sensor classifications. What are the different types of sensors and their applications? Then comes concept of this Swath and Nadir. Generally, this question was asked multiple times in your exams. Then we have this resolution and digital image. And last part comes out to be like the resolution. There are the different types of resolution like this spatial, spectral, radiometric, and temporal. So we'll talk about it. And in the last phase, we will have this image interpretation, visual image interpretation. So in that flow, we will be covering your syllabus of unit number 2. Talking about the types and characteristics, earlier also in your regular offline classes also we have talked about some portion of it is already covered, but today what I am trying to do is basically I am covering the whole syllabus of this unit number 2, irrespective it is covered or not. So starting like based on the source of energy. So we have this active and passive way in which we can categorize. So passive remote sensing, if you see, it uses this natural resources or natural energy like your sunlight or the earth radiation. So next, just sensors detect basically the reflected sunlight. So the natural resources that we have, so it is taking energy from them, and some part of it is absorbed, some part of it is reflected. But when we'll say reflected, so it is taking energy from it. And the types of satellites or the examples for it is basically Landsat and Sentinel 2. Same way, or in the next part, we have this characteristics. So basically, characteristics wise, they have the low cost. When we'll say passive, they cover a wide area, but the negative part is that generally depends on sunlight. As you see, we have already talked about their source of energy is basically the sunlight and the earth radiation. So they have to depend on this uh, basic source. And but obvious if they are dependable, so basically cannot work well at night, right? Going ahead, we have this next part, that is your active remote sensing. When we'll say active remote sensing, so basically it generates its own energy and records the return signal. So when we'll say signal goes and comes back, so basically it transmitted and come back. So in that way it record the signals. And good part or the best part about this thing is it works basically in day as well as in night also. So basically the examples for it are the radar, microwave, and the lidar, right? And the example or the characteristics wise, it works in night also as talked about. Next, it penetrates through the clouds, because whenever you are sending the signals or the radiations, sometimes it happens that is they got refracted, they don't reach to the desired location or the end user. But this is the best part is like it penetrates through the cloud. Then but obvious it is, in that sense it is more complex and in costly also. Moving ahead, we have the different platforms So when we are trying to have this active or passive, or whenever we are transmitting these things, so we need some platform through which we can do this thing. So we have few platforms like airborne, wherein drone, aircraft based or things are there. So you will mount all these things on these platforms. Now talking about when we have this airborne thing, so but obvious we have a very huge area that we can cover. So we will having what? A high resolution for that particular local area. Now when this particular thing, right, if I'll tell uh, this is the earth. In the classroom also I've talked about. So this airplane is inside the earth and at this location, and it will cover this particular area, right? Now talking about the spaceborne, right? So it will be above this earth, right? It will be rotating somewhere here, or depending upon the kind of satellite it is. So it will be taking like the image from this side, right? Here it will be, and from here it will be taking the it will be covering the area. So when we talk about the spaceborne, so it is basically a satellite-based imagery. So you can see clearly the difference from here. When we are taking the images, it will be from the drone, and at the same time when it will be taken from the space, right? So satellite will be taking the vital role, and it will be covering a more large area. So obviously it is covering a large area, but when we'll talk about the satellite, it is covering uh, relatively large area than the airborne satellites. Fine. Moving ahead, we have the sensors, the types and characteristics. So when we'll talk about the sensors, so sensor what exactly they does is they basically detects and record the EMR. So talking about the EMR, that is the electromagnetic radiations. This thing we have already studied in your unit number 1. Fine. So whenever these radiations are sent, so basically the sensors work or task is basically to capture these radiations from the Earth's surface. So basically they may be the imaging sensors or non-imaging sensors. Now, when we'll say imaging sensors, so what exactly they does is they produces satellite images, and this images is used in basically mapping and your land use analysis. When we'll say mapping, they have you have this thing that is man-made, man-made or natural resources. So you basically make a map, and it helps you in analyzing the things, right? And it will be further used in the land use development. Talking about the examples, if you see in the imaging sensors, you will have this multi-spectral sensors and the panchromatic sensors, right? And when we'll say the non-imaging sensors, so they do not basically, as the name suggests, they don't form any images, but gives you the data in a numeric form. So when we'll say numeric form, it basically the numbers, right? They don't give you the directly images. So this data that will be available to us is used in your atmospheric studies. You will understand this data and analyze it. Earlier also I have given the context, giving example like you are using your concrete, you are taking the readings. So basically what you are exactly you are doing is you are getting some data, and later on you are analyzing like is this coming in that prescribed limit or the threshold limit. If it is in that particular range, so basically it gives you the idea, yes, this is fit for use or not. Similar way here, it also you will get the data in some numbers, and you have to analyze it, and accordingly after analyzing you can put up it in the reports. Now the sensors that we'll be using here is radiometers and the spectrometers. Now based on the wavelength region, so these are the basic different sensors. For like optical, we have the wavelength is basically visual plus NIR, and you can use this thing particularly for vegetation and land use. Talking about the thermal sensors, if you see, you have this infrared thing in the terms of wavelength, and With that, what you can do is you can utilize you can see the heat, the temperature, and in the urban studies. In giving a reference or the example, you have seen like in defense areas, what they does is if they want to see, giving example, there is a hostage situation or so, how many people are there inside a room. So those things can be used by these thermal sensor cameras, and also you get this heat of the human inside, and you can capture them, right? So these are the different temperature variations. Even at the remote locations, some avalanche or something has gone, so you can identify like from the heat radiation like somebody is there, right? And in that way you can rescue them. So different ways. It is just I have given you an example of a defense. Same way in the urban studies also for the mining, layering, and different use you can utilize this sensors. Same way this micro and radar, they have the long wavelength and you can use for floods, the soil moisture, and the structural mapping, right? So these are the different applications that you can see based on the wavelength region. Now we'll come to the orbital characteristics of the Earth's resource. When we'll say orbital characteristics, we'll see the what are the different kind of Earth resource satellites. Giving example, the first one is like geostationary orbit satellite. We'll call it as GEO. And we'll say geostationary, which means it rotates with Earth, right? Giving an example like this is our Earth, right? And it is rotating something like this. So when it is rotating, this satellite will be also rotating similar or with a similar pace with the Earth rotation. So when it is moving with the same velocity, that too with the Earth, so it fixed or it looks like it is basically the fixed. Although it is not fixed basically, it is basically what? It is moving along with the satellite. Uh, Talking about this one also, I have given some examples in the classroom also. Give me example if you are sitting in a bus and you are bus or a train and you are traveling. So if you see outside, so it looks like that you are going ahead and the things outside are going back, right? But at the same time, if you are traveling in a bus and at the same time one more bus comes besides you and you will feel yes they are traveling at the they are stationary basically, right? Although though both the buses are what both the buses are
moving.
basically moving, right? So more or less this is the kind of a similar example, and I have a good image for that also. So height is also already given, that is the height is 36,000 kilometer, and that example is basically an insect satellite. So example is this thing helps in basically the weather monitoring, and this is if you can see example in this you can see Earth is rotating, and this basically the image it shows basically this satellite is also moving along with the Earth rotation. And another also I have put up one image. If you see, reason being the Earth is moving somewhat in a tilted way, right? If you can see when it is moving, so it is also moving in that particular way. So this is something a good example of it to understand this particular concept, how satellites and the Earth is rotating and how the different concepts are there. So I hope with this thing, this geostationary part is clear to all of you, right? So moving ahead, we have another one, that is sun synchronous orbits. Sun synchronous orbit. When we'll say sun synchronous orbit, so basically what happened? It passes same place at the same local time daily. So basically, what it is doing, uh, according to sun, if you see, a day is somewhat like 24 hours, right? So in that sense, it is basically rotating 24 hours. राइट. तो वो 24 आवर्स में आपका एक राउंड लगा के वापस उस जगह पे आएगा. तो इन दैट वे जो सैटेलाइट रहेगा इट इज नॉट मूविंग along with the earth, it is basically what it is taking a 24 hours lap time. So if the see with this it will be like height is 500 to 900 kilometers and it is moving accordingly. Now, example is like IRS, Landsats in Intel. So, InSat is somewhat different and this purpose is basically different. So, basically it is taking capture of your daily local time. The example as for best for mapping, changing detection because it is, yes, Shunali has sent a message. Shunali, everything good? Shunali said like, cannot open page because address is invalid. No, beta, already I think 6 people are already there in the meeting. Shonali, if you can, can somebody just, what we can say, call her and tell this already we are in place. That is, the meeting is
Yes,
already
sir.
going on. Yes.
Yes.
Maybe she had some problem because of that she may not be able to join. Okay. So this is basically the when we'll say SSO. So basically it is sun synchronous, and it is has a basic different functionality than your geostationary satellite. Talking about the uh, key patterns when we'll have this kind of satellites and working in that particular direction. So this particular what we can say parameters comes in picture, that is swath, resolution, spectral bands and revisit time. So when we'll say these parameters, so we'll be studying these parameters basically what exactly happens, because when you are taking this data and you are grabbing the data, so some things comes in picture, right? So some concept we need to study basically. So this concept of this Swath and Nadir comes in picture. And as you have seen also, that is, it was asked multiple times also in the exams. So it is a prime understanding. Although I am not saying that is the earlier things are not asked in exams, but let's say to understand this topic, what is the this Sant and Nadir? So definition wise, what I've done is in a very simple way I have given you this concept. That is, Nadir is basically what? This is point directly below the satellite on the Earth surface. Basically, I have put up an image also for this particular concept. That is what exactly is Nadir. So the satellite is basically uh, on the Earth surface. Basically, you are checking a very wide area, and thus Nadir basically what is doing is it is capturing the captured by the satellite the width of the area. So instead of talking in terms of this thing, I think I had this image, and first of all, I'll show this image, and we'll go more depth in this. So if you see this one, this is Nadir and this is your Swamp. So here is basically the satellite. So when we'll say satellite, तो आपका satellite कैसे रहेगा? It is above the what we can say the earth surface, अर्थ के सरफेस के ऊपर रहेगा, एंड वहां से वो डायरेक्टली जब वो नीचे देख रहा है या नीचे आपका पॉइंट आउट हो रहा है, सो बेसिकली क्या हो रहा है, द पॉइंट डायरेक्टली बिलो द सेटेलाइट, तो जो नीचे पॉइंट सेटेलाइट के पॉइंट आएगा वो क्या रहेगा आपका नदीर पॉइंट. Fine. So this is the way how directly these things are coming up. Now when we'll say swamp, तो बेसिकली यहाँ से जब उसका प्रोजेक्शन आपका आएगा, वो जितना एरिया आपका कवर करेगा, राइट? सो द एरिया दैट इज कवर दैट इज कॉल्ड एज स्वamp width, and this is the basically the captured area. Now the thing is, if you can understand, जितना ज्यादा ये ट्राइंगल आपका बड़ा होगा, उतना डिटेलिंग एंड एंड पे आपका उतना बराबर नहीं आएगा. सबसे बेस्ट डिटेलिंग कहाँ पर आएगा? इफ यू सी दैट this particular triangle, it is more what we can say grayish, because वहाँ पे डिटेलिंग्स आपको अच्छे से मिलेगा. सेम वे आपका जितना है वहां पर वो इंक्लाइंड वे में आपका आगे जाएगा, उतना डिटेल्स आपका सही नहीं रहेगा, राइट? सो दिस इज बेसिकली दी स्वाम्प एंड नाडिर. I think with the image the concept is clear. Now talking about this theoretical part, if you see, Nadir is the point on the earth surface that lies directly below the satellite sensor, right? So now you can understand basically, and I expect when we'll say these things comes in exams, So basically make this satellite diagrams also, what I have shown recently right now. Now the key points or the characteristics of this is like the width of the area captured by satellite is 1 पास बेसिकली, क्योंकि ऊपर से ही आपका आएगा इसके अंदर में। एंगल कितना रहेगा आपका, बेसिकली इट इज 0 डिग्री टू और 90 डिग्री फॉर दी हॉरिजॉन्टल। नाउ सैटेलाइट्स क्या करेगा आपका, रिकॉर्ड्स मैक्सिमम ज्योमेट्रिकल एक्यूरेसी, बिकॉज आपका डायरेक्टली 90 डिग्री, तो वहां से आपका मैक्सिमम एक्यूरेसी के साथ आपकी चीजें आएगी। एंड एज यू डिस्टॉर्ट, मैंने आपको कहा कि जितना आप वो 90 डिग्री से जितना डिस्टॉर्ट होंगे, जितना अवे जाएंगे, उतना आपका क्या होगा, डेफिशिएंसी या चीजें डिस्टॉर्शन में आएगा। लास्ट बट नॉट द लीस्ट इज जो आपका ज्योमेट्री और ये जो है इमेज करेक्शन इसके अंदर में इंपॉर्टेंट है। तो अगेन जस्ट सिमिलर इमेज दैट वी हैव स्टडीड राइट नाउ, ये आप और डिटेल में आप बाद में देखिए इसको। नाउ स्वांत, टॉकिंग अबाउट theoretical way, it is the width जो आप ऊपर से प्रोजेक्शन करेंगे। एंड Sonali has joined, right? Okay. So Swant is basically the width area through which the satellite, जहां से आपका प्रोजेक्शन आएगा, वहां से अगेन आप एक पास में उस चीज को देख पाएंगे। एंड डिपेंडिंग अपॉन द सेंसर्स यू कैन हैव द एल्टीट्यूड, कितना हाइट रहेगा, एंड यू कैन मेजर दिस थिंग इन किलोमीटर, बिकॉज जो आपका लैंड सेट रहेगा वो आपका हेल्प आउट कर लेगा। सो इट कवर्स वेरी लार्ज एरिया इन वेरी लेस टाइम। जो स्वाथ है वो बेसिकली क्या करेगा, आपका बहुत ही कम टाइम में आपका एक वेरी लार्ज एरिया आपका कवर कर लेगा। लास्ट बट नॉट द लीस्ट इज बेसिकली जो रिजल्ट्स है, जो स्वाथ का जो रेजोल्यूशन आएगा वो क्या रहेगा, जितना डायरेक्ट नीचे रहेगा वो ज्यादा बेटर रहेगा, उसको उतना अच्छा पिक्सल्स आपका, उतना अच्छा डेटा एक्यूरेसी मिलेगा। जितना आपका सेंटर से जितना डिस्टॉर्ट होगा, राइट, इफ यू सी टॉकिंग दिस वे, यहाँ से सेंटर में जितना रहेगा उतना आपको अच्छा डिटेलिंग मिलेगा, जितना यहाँ से आप डिस्टॉर्ट होंगे, जितना दूर जाएंगे उतना आपको डिटेलिंग कम रहेगा। नाउ मूविंग अहेड, we have what the major Earth satellites program. So when we'll say major Earth satellite program, we'll see the Indian context as well as the global context, right? There are the two things in your syllabus. Uh, Taking this, the first one, when we'll say Indian IRS, that is Indian Remote से सैटेलाइट प्रोग्राम आपके आएंगे, इसके अंदर आपका इसरो भी आएगा। सो वी हैव डिफरेंट सैटेलाइट्स, IRS, Catrostat, Cartrostat series, then we have this Resource Cat series. So they have their own specific use. When we'll say the satellite programs, when we'll say IRS, it is basically used more for agriculture and land use planning. When we'll say this Cartostat series, they have this high resolution and used for infrastructure planning and used for DEM. Last in this category is basically the Retrostat series, which is used for this नेचुरल रिसोर्स मॉनिटरिंग, जो भी आपके नेचुरल रिसोर्स है इनके रिलेटेड काम आएगा। नेक्स्ट वी हैव दिस ओशन कैट सीरीज, जहां पर आप ओशन और कोस्टल जगह का मॉनिटरिंग करते हैं। इफ यू सी वेरियस हाई टाइड्स, लो टाइड्स एंड डिफरेंट थिंग्स कम्स अप, सो बेसिकली दिस takes the data for that one. Last one is basically in that categories. Reset series, basically the radar, which is basically the microwave based, and it helps in basically the flood monitoring and all weather imaging. So basically different satellites, different use, and in that way we'll monitor the data. Now this is basically the Indian context. Then we have this global satellite that are used. Global satellites, what they does is this has the Landsat for the USA, and they have their own program for use for this land use and navigation. They have this Sentinel for the Europe, which have their free and open access, and you can use for Sentinel 1 and 2 for the radar and the optical. So in that way, for like China, then Russia, they have their individual different programs. So right now, for example, I have given you this two examples for this thing. Right, this we have the Spot for the France and the Modis for the NASA. So in that way, they have this different satellite programs for. Now we are moving on for the open source data links, and again this is the one of the important thing that comes in exams, right? We have seen like for 5 marks this things has been repeatedly asked. So the when we'll say the open things, so programs, UGS Explorer, Landsat DRM, then we have this OpenCrest hub for the incidental data, then ISRO Bhavan portal data sets, then we have this Google Earth Engine cloud-based program, then the NASA Earth data, that is model climate data sets. So we have this different satellite programs and data links. Now, last part in this one is coming the digital image, and we'll say digital image. So what it does is basically we have satellites and they process this pictures, and already you are using your camera, you know what is pixels. So basically the data is captured in pixels and these are clubbed together and finally making an image. So basically each pixel is basically has this digital number जो आपकी brightness and बाकी चीजों को control करता है. So example DN0 is black and DN225 is white. In that way, this is coded, and finally, digital image is done. So when we'll say digital image is made, so basically we have this resolutions in uh, remote sensing. So आपका image बनेगा तो उसके related हमें उसका resolutions और बाकी चीज़ भी पता होना चाहिए. So when we'll say resolution, so it is divided in 4 parts, right? 4 parts in the sense is like आपका स्पेशल रेजोल्यूशन रहेगा, स्पेक्ट्रल रहेगा, रेडियोमेट्रिक रहेगा, टेम्पोरल रहेगा. तो इमेज अगर फॉर्म हो रहा है तो बट ऑब्वियस है हमारा उसका किसके साथ कंपैरिजन होता है, रेजोल्यूशन के साथ में. इवन यू हैव ऑलरेडी यू आर गुड एट दिस इमेज, जब आप फोटोज वगैरह क्लिक करते हैं, यू नो इफ किसी कैमरे का अगर रेजोल्यूशन अच्छा नहीं है तो इमेजेस भी अच्छे नहीं आएंगे. क्यों नहीं आएंगे? क्योंकि उसका रेजोल्यूशन का इश्यू रहेगा. So we'll be seeing these 4 parts, that is the 4 things. When we'll say first one, if you see spectral resolution, in this one, you can see the 30 meters in the image, that is 30 meters pixel side, then 5 meter pixel side. So if you can see the difference basically. Similar way, the spectral resolution, we have this panchromatic and multispectral and this hypospectral. So in that way, whenever you are using a different spectral resolution, you can see the difference. So this image basically helping you out in checking what exactly and how different things are will be there. Same way the temporal, and finally the radiometric resolution like 8-bit, 10-bit and 12-bit. So talking about this thing in detail, basically I have given you the image idea. So now what we are doing is how exactly, or the theoretical part of it. First one will go for the uh, spectral resolution, or sorry, not spectral, spatial resolution. The spatial resolution is basically the small, what we are trying to do is we are trying to detect the smallest ऑब्जेक्ट दैट वी कैन सी, राइट? बिकॉज यहाँ पर आपका क्या होगा, डिटेलिंग काफी वास्ट रहेगा, ज्यादा जूम इन करके हम लेंगे. सो ये कौन सी सैटेलाइट्स आपको इसमें काम करेगा, विल हैव दिस लैंडसैट, सेंट्रल 2 एंड कैट्रोस्टैट, जो आपका 30 मीटर, 10 मीटर और 1 मीटर का आपका कवरेज देगा. एंड अकॉर्डिंगली आपको जो पिक्सल कितना रिप्रेजेंट होगा, 30 मीटर बाय 30 मीटर, बिकॉज एक बॉक्स बनेगा ना आपका रेक्टेंगुलर, सॉरी स्क्वायर वे में. तो जितना आपका हायर स्पेशल रहेगा उतना आपको बेटर क्लैरिटी या बेटर इमेजेस आपको मिलेगा. स्पेक्ट्रल बेसिकली क्या करेगा आपका, इट हैज द एबिलिटी टू कैप्चर डेटा इन मल्टीपल वेवलेंथ. तो आपने जैसे देखा होगा कि आपको पैनक्रोमेटिक, मल्टी स्पेक्ट्रल, हाइपर स्पेक्ट्रल, तो आपका बैंड आपका उस तरीके से आपके मल्टीपल वे में चेंज हो गए. सो आई हैव ऑलरेडी गिवन यू द एग्जांपल लाइक बैंड 1 3 to 15 बैंड्स एंड लाइक 100+ बैंड्स. तो जितने ज्यादा आपके बैंड्स रहेंगे उतना आप बेटर वे में मटेरियल को आइडेंटिफाई कर पाएंगे. फाइन. Next, in that category, we have the radiometric resolution. And we'll say radiometric, if you see, what they does is they have this ability to detect small differences in an energy. and examples of bit are like 8-bit and 12-bit. When we'll say 8-bit and 12-bit, they have this levels of like 256 gray levels and 4096 gray levels. So you will get more resolution or the higher resolution when you have the better brightness detail. तो जितना ज्यादा आपका रेडियोमेट्रिक रेजोल्यूशन रहेगा उतना आपको ब्राइटनेस का उसके अंदर डिटेल मिलेगा. In this category, the last one is basically your temporal resolution, and what it does is basically it is used in checking the detection or the changes. So basically, if you see what it does is it gives you the time interval between the different satellite what they covers. So when different satellites are repeatedly covering the images and all, so it basically gives you the difference. And what will give you the difference? If you see Sentinel 2, when it revisit after 5 days, Landsat if it revisit after 16 days. So what they does is they monitor these changes, like after 5 days, what changes has happened. So that changes basically makes you helps in change detection or the flood monitoring. So in that way, these satellites work basically. Now, sorry, we'll see the some sensor applications. When we'll say applications, first thing is like if you see there are the different use. Almost I think I have given you the here the 10 applications in land use, urban expansion. So for the exam point of view, this is fine, but I think this is more appropriate to in terms of teaching. Satellites what it does is आपका land use cover या mapping करने के time पे काम आएगा. It is also used in like road alignment and planning. If you have the taking the initial survey from where you want to take the road, so that's alignment is perfectly done by this road alignment part. Same way, if you want to select a site, you want to see how exactly it will be useful, or you can optimize different locations or development of a project at that time. Again, yes, this thing is particularly most important. Next is soil mapping and erosion. If you see this Landsat accidental satellites, what they are doing is after 5 days, 16 days, they are again remapping the things. So basically, soil is eroding or not, or river is changing its path or not. Same oceans, if they floods and the coastal area are fine or not. So in that way, this helps in different ways. Same way, the groundwater potential or the zone mapping, these things have be done by the satellites. Next is your watershed management. Next, that is your flood mapping and disaster management. Last but not the least is basically your urban expansion or monitoring. That is, if the things are going in a pretty good manner or not, else there will be like haphazard urbanization with no clear-cut guidelines and things. So while making an urban development or DPR plans, so these things basically are quite important for making these things to work in an efficient and productive manner. Now, next part is more or less a visual interpretation. Whenever you are collecting all this data, you will get some things, and finally you have to interpret what exactly you got. The means you what exactly you got from the data. So when we'll say image interpretation, so whatever data you will get, so data will be more of like water body, vegetation, roads, airport, farmland, right? The urban area. So identifying all these things. So basically we have to interpret how exactly or what exactly we can do, right? So basically whenever the satellites put its radiations, so as in there, I think starting of this session, we have seen there are imagery satellites and non-imagery satellites. And we'll say imagery satellites, these are the things that they capture, and finally, these are the interpretation or the use, what exactly and how we are using it. So basically, these are the some things or the elements through which we identify, that is, first is your tone or color, so brightness, So example, water will appear or it will look dark, right? Shape wise like outline, then stadium as color. Size is basically like relative dimensions देगा आपको, like buildings या roads वगैरह के लिए. Texture कैसा है आपका, स्मूथ रहेगा नहीं तो रफ रहेगा. So for forest rough and water smooth वगैरह, तो इस तरीके से आप उसको कैटेगराइजेशन कर सकते हैं. पैटर्न लाइक आप रिपीटेशन है तो आप एग्रीकल्चर फील्ड्स वगैरह के लिए यूज कर सकते हैं. For the shadow, what you can do is you can use for the height to like towers and buildings जो आपके रहेंगे. साइट के लिए बेसिकली विच मीन्स आपका लोकेशन वाइज तो ब्रिज है रिवर के ऊपर, तो उसको आप उस जगह पे यूटिलाइज कर सकते हैं. लास्ट इज बेसिकली एसोसिएशन, बेसिकली जो नियर बाय फीचर्स है जैसे रेलवे स्टेशन है या ट्रैक्स वगैरह है, तो उस जगह की चीज़ों का आप आइडेंटिफाई करके दिखा सकते हैं. तो फाइनली व्हाट वी आर डूइंग इज दिस विल समथिंग लाइक इमेज इंटरप्रिटेशन जो आपका टोन्स वगैरह वगैरह के अकॉर्डिंग आएगा. तो बेसिकली इफ यू सी वाटर बॉडीज का डार्क टोन एंड स्मूथ टेक्सचर, वेजिटेशन आपका जो है वो ग्रीन टोन वगैरह में आ जाएगा. आई थिंक यहाँ पर आपका ये डबल चीज आ गई इसके अंदर, बट दिस इज द काइंड ऑफ थिंग दैट विल हैपन. फाइन. नाउ विद दैट नोट आई थिंक दिस इज द ओवरऑल थिंग दैट विल बी there in unit number 2. With this we end our unit 2 conversation here, right? If you have some questions or queries you can definitely ask. Talking about your what we can say is uh, in some syllabus I have given you the assignment also, and we have checked what exactly and how we can see your questions that will be coming in exams. So first of all, like I'll just stop sharing this one. Now assignment wise already I have, one second, the entire screen share the screen. Okay, so when I'll talk about like assignment wise, so already I have given you this assignment. So in assignment wise, okay, so in the assignment, what best questions can be asked comprising all this stuff. So already this assignment has been given to you. Please utilize these 2 days and try to figure out these answers and write it in your notebook. Through Google Classroom, if you will submit, it will be good. Or you can have the notebook and you can write it down. You can meet me in person and get it checked. So this will help you before your exams, what actual exams for your in-sems. So it will give you a basic idea what exactly to write and how this thing to be done. Already also for this also we have talked in class, but again, yes, it will be a good practice if you cover up this thing also. And in that way, for unit number 1 and 2, you will be in a good shape to write your exams in a very well manner. With that note, I'll say for today, our part is done. If you have any questions or queries, so let me know, else we can conclude this session. Talking about the session, those who have joined earlier or later, I have recorded this session, right? So if some part you have missed, what you can do is go through the slides and just go. I'll put up this link also through YouTube so that you can just go and watch uh, again, right? Those who have missed some part of it. So with that note, if you have some queries, well and good. Else, if not, we can conclude the session. Yes. Anyone? Any questions or queries?
Query. No query.
No, sir.
Okay then.
No, sir.
So fine, fine, fine. So if not, so yes, thank you, and we conclude the session then. Fine.
Yes, sir.
Thank you,
Thank you.
sir.
Okay.